Okay, it looks like we are live. So welcome back. Today I'm going to be continuing to work on my virtual machine. So I'll put the link in chat. So let's take a look at what we've got so far. So if we can build all the tests. This won't work though. So we'll let it build. And yeah. So I'm not sure why that one broke actually. I wasn't expecting that. Let's see. So let's run it from here. Expected that. So did I mess something up? I seem to have broken it. It's not very good. Um, but the fib still seems to work. Yeah, so that still works. So it is something to do with that. So that's on the first line actually. So, all right. Let's see. So expected that. Yeah. So in here, so this break might not work. Is there a different way to go about doing this? Well, I think I can test it in Python perhaps. So if I'm not sure if it works the same, but all right. So that does work. Whoops. All right. So let's go back in here. It's not that one. All right. So current index. Well, let's print f current index is and c current index, and we need to go ahead and do this. So I should have tested this before the stream. Expected that. Oh yeah, I need to rebuild it. Current index is p. So let's. So it seems to go. Seems to just have skipped to the next one. So all right, well let's comment this out and see what happens there. Oh, whoops, I need to all right, TASM s/hello world. All right, so we still expect that, but now the current index is d. So, that is strange. So let's see what we can do. Let's modify hello world. All right, we can actually get rid of this because so it goes to d. But otherwise it is here. So there must be a problem with reading the file. So let's try to modify it. Actually, we can leave the same, and we will. Let's print it out. Let's see. So can we print? Yeah. Let's just print the entire current, and let's see what happens. Okay, so here it is. That looks fine. Print it twice because we do. Current index is p. So tad strange. Expected that, but it was p. So it goes to here. Expected close into that, because that's really what it is. So all right, so the current index is that. All right. So So then it becomes P. Okay, that is weird. So why is it different? If we do this, it becomes something different. Which is that? To be honest, I have no idea what's going on. Unless this is the next one. So I had this working at one point. So let's see. All right, let's look at this and let's see in the Lexo.c. Can I see the whole thing? I don't know how to do that. So does this show it in here? If I look down here, generate char. Let's see. So current index plus equals 1. So what is different then? Perhaps it is something leading up to the generate char. So let's actually look here. If it is this, then do this, and then minus minus. So that doesn't look different to me. So okay, and then it works. So that, it doesn't like that. I'm not sure why I added that then, if that breaks the whole thing. Yeah. So let's see if it works now. I'm /hello world.t. And yeah, okay, so that works now. So let's get back to what we were doing. So yeah, that doesn't work. That's what I was expecting to break. So this one, macro test, basically, it is based on the folder you are running, or the directory rather, that you're running it from, and not where the file is located. So so that is why it fails here. So we have to do something like this, and then run it. .tin, and then it works as expected. Yeah, so we can include files now. I believe the error handling is working now. It's a little finicky, so it might need some work and we might run into some problems with that, but it should be working. So yeah, let's actually so let me actually commit that thing. Removed problem which made the generate char function not work. Basically is what I did. So yeah, we are going to be working in that function though, because that is what I want to work on. So basically, make sure that went through, and then I can talk about it. All right, no, because we are on the wrong commit now. So let's go to main. All right, and there we go. All right, it went through. So if I can exit out of this quickly, what we do not support at the moment, I'll actually do it right here. So let's see, basically escape character dot as. So we cannot escape character. So if we push new line, something like that, and then try to print it, yeah, we're gonna get an error. So if we run that, expected close parentheses. So that's kind of what I want to get working today. We need escape. So let's look at escape, a list of escape characters, because there is quite a few, more than just new line. But can we see escape sequence? Because if we have a list of them, then we can check for them. All right. So single quote. So we don't need to worry about double quote. No one uses octal. I don't know whether I'm gonna add these, any of these things, because I don't. Should probably eventually add this to the preprocessor, but I'm not gonna worry about that now. But yeah, so these are the ones that we need to work on. So new line, horizontal tab, vertical tab. So we can basically, I think this should be fairly easy. So if we open up the tabs in Lexer, and we go back to generate char, then in here, yeah, so we need to let's see, does not equal that, and current index does not equal valid, or, and let's see, actually I want to do it like this, valid escape character, current, and then current index. So yeah, that's what we want to look at actually. Yeah, I can pass like that. So if this is true and this is true, and it is not actually, so something like that. So valid escape character, we can make a function for that. So let's see, it'll be int valid escape character, and we need the current and the current index. So basically, we're just gonna probably a switch statement. So switch current index, and then case of n. Alright, so yeah. So n t. What are all the other ones? So yeah, we'll basically just copy these over. V backspace R, and then form feed a backslash. So it needs to be double. So yeah, in this case we just need to check that. So then we'll also do if current index plus 1 not equal that, then yeah. I think that's how we need to do it. Then yeah. So then we have another case for question mark. Why do you need that? I don't know. Case single quote, and that is all that we need actually. Something like that. Yeah. So now we can handle it. So we can basically just yeah, we'll just return from here. So return 1. Actually, any of these we can just return 1. And then default, you'll return 0. I think that should work. So if it's not any of these, then it is invalid. So is that where we want to check it? Actually, so here we don't want to check it yet. We want to check and current index does not equal a backslash. That's what we want to check. So actually, I don't think we need this extra check here. So then, maybe we actually want to do that too. So we want to do if current index equals backslash. Then we'll do something else. So basically, we'll just we'll do something like current index plus equals 1, and then if current index is not equal does not equal, or no, we need to do it that other way that we had. Valid escape character current index. So we'll check none actually. Then we will do printf. We can copy this actually. That's it 1. And what we will do here is we will say error invalid escape character. So yeah, I think that should be good. Otherwise, we'll continue, and then we'll set. So we basically want to make the character name this as well. So character name 1 equals current index. And then here we need to change this actually. So so we can get rid of this now, because we should be there at this point now. Valid escape character. So we do need to iterate it, I believe. Yeah, so then current index equals 1, and then here it should be that. And so I think we can just have basically an int is escape equals 0, and then here we'll just set is escape equals 1, and then if is escape, else we'll do this, character name 2 equals that. Actually, I think a simpler way to do that would be take this and then do character name 1 plus is escape. Because then that way if it's 1, it'll become 2, and otherwise it'll just stay as 1. So yeah, that is actually much cleaner. So let's see what we get now. So if we build it, expected expression before case. Oh yeah, so I need to right here need to do that. Okay, so now let's run asm escape character. Expected close parent. So it did not work. Blah, blah, blah. Perhaps I don't need to iterate here. So let's see now. No, all right. So that's not the problem. So let's print f current and current index, and let's see where we are at. And okay, so we need to iterate again. So perhaps, so if current index equals that, let's actually print the current index up here. See what it is. I'm not gonna worry about indentation. N. Okay, so why? So why is that? You know what? I think we need to do this check earlier because here we're setting the character name equal to that. Yeah, then we need to do the check before we iterate it here. So let's just go down here and let's do that. So expected close parent. Alright, so it still didn't work, but we are closer now. So that's a slash. So this, make it in there. Now I think we are going one too far. And yeah, so that is actually the problem. So if we get rid of that, now it should work. And then escape character dot in. And alright, so it didn't work. Because it is not one character. So yeah, so how do you like merge a character? Because yeah, we want it to be that. Because right now they're being treated as two separate characters. So how to basically how to merge two characters in C. That's what we want to have, the slash character and the end character, and then merge them. So I'm not sure how to search for this exactly because let's look in our virtual machine actually. So temp.c. So I don't think I need this here. Let's get rid of that. So if we look up here, so here we are printing as char. So I think it's in the push where we need to look. Push up here. Yeah, so maybe in the let's see. So increment character by 3. So what is so what is the character actually? Character equals 1. So what is the character for? Character plus. Oh yeah. So that is actually, that has to do with that. Okay, so I think we need to do something like that. 3 plus is escape. Then I don't think this will fix it, but for the air handling, it'll be better. Whoops. Yeah, it still doesn't work. Basically, convert string of escape to character in C. Let's actually print out the character name. Okay. Character name. And let's see what it prints. Yeah, so it's slash and then n. I suppose in here, to make this a little bit more complicated, where basically it will just return slash n. Something like that. And then here we can return that. Yeah, and all of these are gonna have that. And so yeah, it's not gonna be an int anymore. Return an empty one. Would want to just return the current index though. Why don't character? So yeah, let me make these all correct. So this should be B R F A slash and there we go. All right, so for this, basically we need to do this a little differently. We can just let's just return no, we can't do that because we are checking that. So how are we going to go about doing this? So we want it to yeah, so if it's a backslash, then it's going to return that. So as long as basically we can do escape character equals I should probably rename this function because it's not really checking if it's valid anymore. Current and current index. So I will do that. And then here we can just check if escape character equals nothing, then yeah, we have an invalid escape character. Otherwise, we can actually set this equal to escape character. And then we don't need this is escape anymore because we aren't using that. So then, yeah, this, we can get rid of everywhere that we use that. Yeah, so now let's see. We build this, and there is empty character constant. All right, so we need to just return, a space. Maybe we should just return the \0. Perhaps that would be better. So, all right, and then escape character dot. And all right, so that seems to work. So if we change it to if we escape character, hello there, Cloud 90,001. How are you doing? Yes. All right. Let's see. So let's try that now. And there we go. All right, so I'm assuming that's working there. Kind of hard to test that, but it looks about right. So we can get rid of this one. And all right, what other one? So let's actually try that one. So if we run this, I'm doing fine. All right, something wrong. All right, that worked. Is there a space? No, I think there just is a space. So then we can change this to be double backslash, and that should work. All right, and then do this. What else? What other characters were there? Question mark. All right, so I don't know why you need that exactly, but it was in the list. So all right, question mark. So can you not just have the question mark be a regular character? Suppose not. Yeah. So what is F again? Form feed. All right, yeah. So I don't think I need to test all of these, but that worked. And then this one can just work because There's no problems with that. Yeah. Alright, so that is pretty good. So now we have escape characters, in the characters at least. Actually, I should probably add this one. I didn't even think about that. So that's like the end of string character. Yeah, so I'll just take this and then do that and that. Invalid escape here. Alright, did I not? I like classical music. That is cool. What kind of classical music? Like Beethoven or a different one? Escape character. Alright, so why doesn't that invalid escape character? Alright, I guess it doesn't like that one. It is alright, and let's run that on there. Alright, so it doesn't like that. Actually, it's because this needs to just be 0. Okay, yeah, so I just messed that up. Like Luigi. Alright, let's see this one. Alright, listen to this one. Let's see. Loading. Alright, am I allowed to play it? I don't know how the laws work. Let me see. I'm gonna try to figure it out. Ba ba ba. Alright, let's see. Alright, I don't know if I'm allowed to play that, so I cannot listen to it right now. But I will save that to listen to later. Yes. Okay. Very cool. So, yeah, let's test if this works now, actually. Escape character.asm. Alright. Escape character.tim, and there we go. Alright, so I'm assuming that worked. It's kind of hard to tell, but it's a public domain. But even if it's in public domain, you still can't listen to it, right? Alright, I will all believe you. Hopefully it doesn't get taken down. Alright, yeah, give me a moment. Let me just get rid of this for now. And then I will play it. So, alright, that's all good. So let's see. I have, alright, let's start over. I'm not talking right now. I was listening to it while I was doing this. Yes. It's a good song though. I enjoy it. Yes. So I will not play the rest for now. Yeah. So basically I'm just moving this into the wait, could you hear the song? I guess I didn't think to check that. I don't think I'm recording the desktop audio. Yeah. I forgot about that. Let me see if I can figure out how to add that. I don't know how to. Why are you making a virtual machine? To learn about how virtual machines work, and then going to build a programming language for it, which compiles to the bytecode of the virtual machine. So that is the purpose of it. Let's do that. What are all the characters? T, B, B, R. Alright, so that didn't actually work. I need to open it here. Forgot about that. Escape character. Alright, actually it did work. So I was talking about the other one. That was the problem. Alright, so R, F, A. That one. And then question mark, and that one. And I think that is it. So we will save that and print them all. So how many do we have here? 11? Alright, so I will do 9 of those, and there we go. So that should work now. So, I cd dot, whoops, I went to the wrong one. Alright, I will exit out and do that. There we go. Alright, so now test/escape character. Escape character.tim, and there we go. Alright, so it looks like they all worked. I'm assuming, but should work. I don't see any reason why it wouldn't. Yeah, so now we have escape characters, fully supported. I can just close out of that, because it is gone now. So, let's see. So now there was another error. Actually, right. So, in here, we can import them. And I think I got all this working. Before, a lot of this stuff wouldn't work, but it should work now. And, alright, no, it's time. Alright, yeah, so it looks like everything is working there. I didn't actually try it. You can define macros twice, which maybe shouldn't be allowed, but it's not that big of a deal. And it'll just overwrite whichever one you use. Whichever one you define, rather. So basically, what we need now to make it better, we need pointers and also strings, which would be implemented using the pointers, to be able to push those to the stack. And we do need some way to allocate memory to the heap. That is rather important. And once we have that, like working with strings and then allocating memory and pointers and all that stuff, it's pretty complete. Like we can do a lot of stuff with that. Then we would need ways to interact with the operating system, like syscalls and such, which I think we can use like the Windows ones, or not the Windows, I mean the C wrappers for syscalls. So like write and such, they don't have every single one, so we would need to make a way to implement it ourselves. So we could just make a standard library full of the syscalls, but like we could implement write, where you just write out write, and then it takes the pointer at the top of the stack, and then basically that just points to the start of the string, and then it just goes through the string and prints it, or and writes it. So we could have write, and then there's some other ones that C has. So let's look at all of the C syscall wrappers. Because I forget which ones they have wrappers for, like obviously opening files and such. System call wrappers. So yeah, sockets too, that is important. And I'm pretty sure it should all be cross-platform to work on any operating system. Macro syscalls. Bespoke. So oh yeah, so this is how you can call syscalls that don't have wrappers. You have a cute voice. Thank you. Alright, syscall. So yeah, sysgetID. Alright, yeah, so we can call syscalls like that, which we'll need to do that once we implement our own that C doesn't have, because we want the syscalls for every syscall that you can make. The only problem is that it isn't really cross-platform, I guess. So I'll need to think about that, because we do want it to be cross-platform, but we want to have a lot of functionality. And I don't want to have to re-implement things. So let me see. So I think I can commit what we have here. Added support for escape characters. Alright, and we'll push that. So if we take a look, let's see. Okay, and it worked. So that was finished pretty quickly. So I need to think about what else I can do. Let's look in 10.c and 10.a. In here, here's our instruction set. So in here, if we add a pointer, it could just be a void pointer, and then yeah. So it's something like as pointer, something like that. And then I think that should just work. Yeah, okay. So then we can use that so we should be able to push. We don't have support for it in the assembly though. So let's go to 2.c and let's go to the print, and then we'll print it out as pointer, and we'll print out the pointer, and then so let's see what that does actually. So time test/fib dot test as pointer. All right, so this is where it is stored. Okay, so you would push a string. So let's look at sort of the syntax that would look like. String dot test. So you would push something like this. Hello world. And then what it would do is on the stack. So just imagine that this is the stack, right? Stack. So it would push. Whoops. It would push something like that. Each character. This is if you are allocating the string on the stack. And then there would be an end, like a null termination, and then right at the top it would be pointer to h. So here we could just do something like that, and then here it would just be 0x0. So then it takes up 2 extra characters because there's the null character and then the pointer, or two extra spaces on the stack, but that's all right. And then you call write, and it would look at this pointer, and then it would basically jump here, and then it would go through each one of these. It would pop them off so that they aren't on the stack anymore. Yeah, pop them off the stack, and then it would pop the pointer off the stack as well. And then it will just basically, it'll know that's the string, and it will write that. So I think we could do something like that. So let's implement it on the level of the assembly first. So let me actually delete all this. So that's what we want. Push hello world. So let's asmlexer.c, and alright, so we want to check if it is. So here we're checking that. Else if current index equals that one, then we'll do this stuff. So I need this here actually, and there we go. So instead of generate character, we'll do generate string, and it will be quite similar and pushed up. All right. Yes. So then I think we want to do current index minus for this one. Maybe not. We'll see. We'll get there when we get there. So let's actually just copy the generate character. And then so here we need to do character name. So let's actually add to this. Right under this one. We'll do that because we are going to need that for the strings, to have the escape within the string. So instead of generate char here, this will be string name. String name. Okay, and then current index +1. So we're at the open parentheses here. And then we go to +1, so we're at the start of the string. So we can do if current index equals, let's see if it equals that, or current index. It basically, that's actually all that we need to check, because there can be anything within the string. Yeah, so if we do that, then we want to basically do that, and then invalid string, basically. Invalid string. We can make that in a message better later. So now we want to do while current index is not equal that, and current index is not equal the termination, then we're gonna do current index plus equals 1, and we are basically gonna set string name string index equal to the current index, basically. So yeah, we're gonna need to make that bigger. And we'll need string index, and we'll start at 0. So we're iterating that each time, and we need to iterate string index as well. We use ++ for that. Yeah, so we'll do that, and then at the end, we will need to check this as well within the loop. So I think we can kind of just copy this. There we go. And then we'll place it here. Well, I want to learn coding / programming, but I don't know where to start. Do you have any advice? Well, I would recommend basically just getting started. Just look up a video, how like any programming language you want or whatever. Just look up, try to find a beginner video, and then just follow it and try to build stuff. Really how you get started. Yeah. Alright, so current index plus equals 1, and then that. Okay, escape character equals that. Character name. So yeah, then we need to set string name, string, yeah, we actually do that down here, so we don't have to do that. So that should be good. Now we should have support for escape characters. Thanks, man. I guess in the end, the most important thing is just to start. Yes, that is true. Alright, so we don't want this. We want to do string name, string index equals that. And we need the semicolon. So type equals type string. So we need to add that. Type character name. So this needs to be string name. And there you go. Let's see, place equals string index, and there we go. Alright, so let's try building that and see where we get errors. So, alright. Yeah, so this needs to be renamed to generate string. There we go. And then type string is undeclared. So, as on lecture.h, we need to add type string. We have type char, so let's do type string. Okay, and now type string not handling switch. That is okay. So, whoops. There we go. Right here, we can add type string towards the bottom. Let's see. So type char, type string, type of string. Alright, there we go. So that should work now. And we still don't handle it everywhere. In the parser, I don't think we have any switch state. So I don't even think we need to do anything here. But in the actual, let's see, it is called time.c. In here, no, it's not called that. It is asm.c. That is where we need to change some stuff. So we should have a switch statement in here. Or we do not actually. Yeah, alright, so we need to actually add a check here. Type string. Alright, so we do need to modify this. Modify this to reflect string. Because basically we need to iterate through the value of the string. And we will get to that. So, alright, I think that's all that we need to do here, but I do think we do actually need to do something in the parser. Yeah. Alright. I'm sorry, I'm not sure how to pronounce your name, but you just followed. Thank you, I appreciate that. So, in here we need to check, this same place. Yeah, we can just add to this. Lexer token stack index type is not equal type string. Type string. Alright, so let's see actually. So we can build this, it should work. And then string.title. Expected close print. So we need to actually fix that. Expected. Someday I would like to be half as good as you are. Well, I'm not actually very good. It might seem that way when you don't know very much, but someone just has to know like just a little bit more than you, and then it seems like they're very good. That is how it works, because you don't understand it and they understand it, so it makes them seem smarter. Yes, but you will get there. You will get there. So this is actually in the generate string. We need this to be expected close print. Yeah, so actually it's not a parentheses, it is a quote. I started with JavaScript basics and it is very interesting. It is interesting. JavaScript is interesting as well. It's an interesting language. It was made in like 2 weeks or something, the first version of it. So that is interesting. Expected close single quote. Yes, we need that, and that I think is where we're being hung up. Yeah, expected close quote. So, because this needs to be that. There we go. Alright, and it still doesn't work. Okay, this can actually be just that. Alright, so so perhaps we don't need to do this because we are at the end. Yeah, that makes sense. Yeah. And there we go. And this one, it's not going to work because we don't have support for it in the virtual machine itself. But if we actually add push to our operation, string.tasm, or if we add print rather, it's not going to work because it's just going to print out the first character, I think. Alright, so it prints out, yeah, the first character. That is what I expected. So what we need to do is push it, each one individually. So that is actually handled in here. We have this. So, if type is string, then, yeah, so as char, as pointer, we're going to push the beginning of the string. So we need to do that. Let's see. We also need to do wall instruction value. Let's see. Instruction value. No, actually, wall head value dot text not equal that. We are going to do this and push it as a character. And we need an index. So I. So yeah, we can say in I equals 0 and I plus plus 0. So this could be a for loop, but I don't feel like doing that right now. So so that should push the entire thing basically, and then it'll stop at that character. But we do want to push that character. So let's see, how can we go about doing that? I guess we can just at the end we'll just go ahead and do this, and we will push. We'll push this one. Whoops. What are you coding right now? To have some context, because I have no idea what you were doing. Basically, virtual machine is it is basically simulating an actual, well, simulating an imaginary machine, essentially a computer. So you have an instruction set, just like any CPU would have in a computer, and then you do certain things based on the current instruction. So if we actually look here, this is where we execute all the instructions. We can do different stuff based on whatever the instruction is. That's basically what that means. So then I'm building an assembly, which is basically just a language, a program language, which then gets compiled, which can then be used with the virtual machine that I built. Yeah, so that's basically what I'm doing, if that made any sense. So, let me comment out this one, and let's actually print the stack. Wow. So let's see, stack. Right here, we'll just do stack. Which I think I have to do something like that, and then we build this. Oh yeah, I need to check. Let's see, that is in the parser. No, it's in here. So where? Yeah, this one we need to make this hot. So now let's see. All right, that should work now. So string.tasm. All right, string.tip. And so there is the stack. Okay, so it doesn't seem to have worked. Because we need to actually we need to make more instructions. We need to initialize the instruction each time. Yeah, so here we are creating a new instruction. So I think we can do something like this actually. We push it each time, push the instruction, then it will modify the instruction, but it will be pushed. So let me see. Actually, I need to run this again. Invalid size. So that doesn't work. Alright, let me go through this. I haven't worked with this in a moment, so type equals that. So we need to instruction equals this. Alright, and let's see. Alright. Stack underflow. Alright, so that didn't work. So let's print out each character that we are looking at. There is that. And we want to do, let's see, head value.text I. And let's see, we should have all the characters. We do indeed. So it just doesn't work properly because so that should all be fine. So let's see. Try that, and yeah, it still doesn't work. So program is that. So let's see. Let's do int string int equals that, and then instead do this string int There's that, and then push the string ints. And then here we can do that. That doesn't work. That doesn't work because this needs to be, whoops, and I don't know what I just did. Yeah, string ints. And now we can, go ahead and do that. Alright, and let's run it on string.chasm. Okay. String.tim. Alright, still did not work. Okay. Let's actually go down here and let's print the string ints. And we'll just do string ints. It's a string ints value. Basically is what we want. Let's do that there. Yeah, alright. For value dot as char. And now if we run this, it's not gonna work. Yeah, so it is just that stuff. But if we do this, it should display string ints is undeclared. So let's actually inst string ints. Maybe uninitialized. But let's see. Alright, so we segfault when we do that. Valid side of inst. Do something like that, and then alright, so it doesn't stay. And that time it just prints random noise. And here we print the correct value, but it goes away. Where do we iterate program size? Or what do we do with it? We just pass it in from there. Okay. Program size, okay. Size plus value. Okay. There, okay. So that should be pushing the value. So let's see, can we actually print, let's see, print the current value of the program, and let's do program size, or yeah, we'll just print that, and let's see, will that work? Get rid of that. Alright, array subscript is on integer, so this is yeah, alright, so we need to actually get the value. So we do something like that. Word, yeah, so we need to do as character. As char. Alright, and let's see. Alright, yeah. So what if we do that here? And what if we do it in here? We don't actually have any strings, so let's or any characters, I mean. Oops. Chasm test / hello world.chasm. Alright, so it does that. But what if we do program size -1? And now when we run that, yeah, so that works. That is the current hello world. Yeah, so now let's run it on string. Actually, we can't do that yet because let's grab that and we'll put it there. Chasm string.chasm. And okay. So that worked. Okay, so that looks good. The problem is that it doesn't actually work in the program. Oh, you know what it is? We need to add an individual push for each one. Yeah, okay. So, yeah, we need to basically we need to push program. Set the yeah, okay. I see what's happening. Yeah. Yeah, so instruction type. So let's do string inst actually. String inst type equals. We can just do that. And then each time. Alright, and let's see now. String.asm. And alright, so it still didn't work. But I think we are closer. So we are doing that, and then we push the program. So we do need to do this one as well. Do we need to do that? I don't think we do, because we do set it up there. So push program. So that should be working now. It should be pushing each one, but it is not. So let's actually look in here for the push, and let's just print out what the value is. Printf value is C, and we'll print it as stuff because this is just temporary. Instructions key dot value, and let's see what happens. We need to do dot, or whoops, we need to do as character, as char. And now if we run that, alright, so we don't have any pushes. So if we make this type push, alright, so that doesn't work. Was that, where do we do that? Oh, you know what? I think I need to modify the h in here because we have maybe not. Well, let's see. So can we actually print what we have here? So let's print that. Instruction is that, and then we'll do pretty token, and we will print out the head value type. Let's see. I don't know if we have that token type. Expected token. So alright, let's just let's make a token, I guess. So token equals type equals head value dot type, and this is just temporary, and we'll just pass that into here. Yeah, token. Alright, and let's run string dot asm. Instruction type of string. Cat asm string dot asm. So we should have push though. Oh yeah, but this is actually in there. So head value type. Instead of this, we can do type. I can type push, and then we can, oops, yeah, let's actually take this and let's put it up here. Actually, I already know what is up there, so we don't need to do that. Let's see. Alright, alright. So that is more like what we wanted. It is backwards. I think that's okay. Hello. We do miss the O. Hell world. Alright. Did I spell it wrong? Hello world. Alright, I did not. So it just doesn't like that. Hello world. So why is it hell world? That is interesting. Stack is that. It should also push this though. But it doesn't seem to have done that. So let's do that actually. Now let's see, string.tim. And now, alright, so it did push that, which is what I wanted. But now we don't have the other L, so there is problem here. So, alright, so we are printing. We don't want to print at the end. So let me modify this and get rid of the print statement. And let's see. Alright, string.tagging.tim. So, yeah, okay. So value is, let me run that. Yeah, so it doesn't have the L or the other O for some reason. Why would that be? Let's see if I can figure that out. So back here we do have it. So we do have it. That is, I'm not sure what that one is about though. Oh, well, that's just because we're printing it for there, so that's not a big problem. Yeah. Alright, now we just are missing the L, so I think it probably, yeah, it just depends on the memory. So why is that? Let's actually print the value in here. Value is head value.text I. And let's see. So value is, yeah, actually we want it from here. So hello world. So we do that properly. Let's see. But then that one just doesn't work. Let's go back. Let's print the entire stack again. Can we just... Let's see. I guess we'll just print it here. And yeah, so that does miss some. So for some reason it does, which is interesting. World, yeah, HE, and then it's just a blank. So why is that? All right, let's get rid of that because, well, we'll leave it because we'll need it, but I will just comment it out. All right, so perhaps this is instruction set. Then in here, that is different. We don't ever encounter those, so that doesn't matter. So long as we add the right things. So that should be fine. Okay, instruction value as pointer. Yeah, so we're not doing that yet. We need to just find out where the L and O and all that goes. So get rid of that. String dot add some. Got 10. Alright, so for some reason this doesn't work. Push the program. Okay, type, head equals head next. And it's properly done in here. Let's see. So that's not head value dot text. Pretty sure I already checked this, but let's just check it again. And yeah, so all of those are fine. But then when we actually push it, it doesn't work. And we don't really have a good way to just view the instructions. Like a disassembler would be helpful. Okay. As character. Actually, it's probably because it is of a type string. So we don't want to do that. So if we go back here, we're gonna push. We'll have each one be a type of character. So that is in here. Let's see, where's that at? Type character, because that's what each individual one is, and then the last one, which is the pointer, can just be a type pointer actually. So I don't think we even really need type string. We do need it to check that. So let's actually, So that's a bit interesting. I think that could be where problem comes from, perhaps. Maybe not actually. I don't know why that would cause a problem. Let me change that back. That's gonna break it. Type string. So what? String instruction. That should be fine. String that. Yeah, that doesn't work still. It's not even the same amount of characters though. Or I guess, well, 12 and then, yeah, so it is 12, but perhaps we need to do that. String.text. Yeah, so that didn't actually help. That just pushed that twice. Which is not what we want. Not tagging. Yeah, so I'm not even quite sure how to go. Perhaps we could open a debugger. Yeah, maybe I'll do that. So let me modify the build.sh and we'll add, for this one, we'll add dash ggdb, something like that, I think is how it works. Okay, and now I will open up this project C/Tim. And then we'll do gdb, alright, and then we'll put a breakpoint on run instructions. Alright, and then run. Yes. Okay, and let's see. Let's step through it. So, and let's see. So, what? Break on me. Alright, there we go. So now we go in here. Oh, you know what? We need to add the. Okay, exit out of this. Exit. There we go. So let's do that time. And then string dot head. And there we go. All right. So breakpoint on main, and then TUI enable, and start. Yes. All right, and we'll step through, and that should work. Okay. Oh shoot, I didn't want to go through all this. Let me actually. Let's start over one more time. And we'll do TUI enable. We'll do breakpoint on run instruction. Then we'll run, and we should end up there. Program is not being run. Okay. So that doesn't work. Can we just do breakpoint on none? Alright, yeah, so that should work then. Run. So it doesn't like that. Breakpoint on main. I will step through all this, and we get to see that stuff. I don't use a debugger very often, so, yeah. So I'm not sure exactly how to use it properly. Okay, a lot of stuff going on. I can just do that. Alright. And hopefully we are close to the end. Okay. Man, there's a lot of stuff that goes on behind the scenes. Yeah. So, almost there, hopefully. Oh my. Alright, actually, let me put the breakpoint actually on line 6. There we go. There we go. So next. And then alright, then it does end. So how to add an argument through GDB. And actually I should do this over here. Let's see. With command line alright. So let's do dash args, and actually I want to do that, so string dot has. There we go. And now we enable, and let's add the breakpoint on 9 and run. And alright, there we go. That's what we had to do. Alright, run instruction. Okay. So then it exits. Alright. So I need to do breakpoint on run instruction. So run. And next. So run instructions. So let's actually print machine program size. Actually, machine instruction IP. This might not work actually. P dot type. So let's do next then. Let's do it here. So print machine instructions IP dot type. Alright, actually the dot type isn't gonna work, but we can print the dot text, I think. I forget how you enable it to show, so I don't have to type it. P dot as L. Okay, well, because it's not, it should be a print. Or a push, rather. Right, so why is it all, machine instructions IP dot all right, that's charm. Okay. Okay. So why is it? Oh, because you're supposed to do it. And I am stupid. Okay. So I ran it with the wrong one. So let's add the break on run instruction, and then we'll run. Yes. And all right, now it should be better. So print. It's a push. So let's actually print the machine instruction IP dot value. So H, that is fine. So then it pushes it, and then we go to it again. IP dot value. All right. How to display variable in VBU. Let's see. So that's what I'm printing all of them. Go machine. Instructions IP dot the. Alright, that's the point. How do I show it? While debugging. Okay. Using the commands. I just need to. I just want to display the variable. Display. Display. Is there like permanently display it, not have to print it every time. How to show the. Alright, let's see if I can find it. No. Viewing data. Okay. So that is pretty helpful. IPA. Yes, no. Pretty function. Alright. So that's not exactly what I want. Okay. Info locals. For R's, that's not what I want. Can I just set like value equals machine instructions IP. No. Alright, so that doesn't work. Can I set? Set variable. How to modify? Alright, so I don't want to modify it. I just want to be able to easily display it, so I don't have to type it out every time. I'm not sure. Whoops. Let me just do help and then see what we have. So breakpoints, data, files, internals, running, stack, status, support, trace point, help all, delete, no, dump, print object, yeah, I don't know, I'm not sure, I am not sure, I will figure it out at some point, but IP dot value, and let me just copy this. I can't even copy it. Let me just type it over here and then I'll copy it. IP dot value. Right. So hopefully it allows me to paste it. There we go. All right. Yeah. So that'll be better. So E now. And yeah, it's still E because. All right. Now it will be different. So now it is 0. So it should not be. It should be L. So so yeah, why does it get to be that? Okay. Yeah. So this is where we're at. It thinks it's 0. So if we just make this dot or something, dot, and then we do that, hasm string dot hasm. Okay, so that's what it's doing actually. Okay. So it's not. So it seems that we're breaking out of this and then going back around. So that seems to be possibly what it is. If we print this here and then we also print it out here, then we can see. Actually, let's do broke out. And then I don't care about the rest. And that hasm. So broke out is. So for some reason, it is setting that string inst. So I don't know why. It's setting it as a dot like this. Rather than something else. So yeah, whatever we set this to is what that will get set to. So then in this case, just a space, or it could be an L. Yeah, and then it becomes hello world. So that is interesting. So what can we do about that? Why would it be doing type inst? Push that. Maybe if we just use inst, like the regular inst. So this one, instead of being string inst, let's see, let's do that, and then we'll just use instruction. And let me not redeclare this. Instruction. And let's see, is there anywhere else? We can get rid of string inst. I can string dot chasm. Hello world. Alright, and then if we make this that one, then okay. Hello world. So we don't have this space, which could be an issue. So why do we not get the space? So let's see. We do have it in here though. Because the space stays there, but then it doesn't print the space. Quite interesting. So let me print the stack, and then we can get an idea of how it is step by step. So that's the N. Let's go back to there. So it just prints the comma, and then it goes right to the W. Alright, that's interesting. I think I will push this. I got the bare bones string support added to the lesser, and the VM needs to push the pointer, and for some reason the spaces don't work. There we go. So we'll push that. And then let me exit there, and let me just try adding a few more spaces and seeing what happens. String dot pattern dot 10, and then we do get 1, 2, 3 spaces. But with this one we don't get any spaces. That is strange. So I don't know why. So one of the spaces just gets removed. It seems that we are skipping over it. I'm not sure why. However, I will have to go now. So I will make sure that it got pushed properly. There we go. That seems to work. So yeah, that's gonna be it. Thank you for watching, and I will see you next time. Bye.